Good evening, friends. Today we are going to see about the two-wheel self-balancing robots. These types of robots are able to balance themselves. The balancing motion is is performed by translating themselves to and fro. These type of motions can be able to done by using the sensors. Those sensors are connected with the microcontroller. The microcontroller is act like a brain to these robots. The balancing robot control system comprises of three main items. They are controller, actuator, and the sensors. Let's see, first we will see about the controllers. In this project we use the iBot controller running on RoBIOS version of 5.2 is used to control the balancing motion of the controlled robot. It is a very powerful 32-bit microcontroller running at the speed of 33 MHz and having 512 KB of ROM and 2048 KB of RAM on the board. The programs to the controlled robot can be written in a C or assembly language. Then we see about the actuators. The actuators are nothing but they are DC motors used to give some motions. The actuators are used to produce actuation to balance the robot, and they also used to locomotion of the robot. The actuators are fitted with the wheels of the robots. Let's see about the most important portion in this project called sensors. These type of robots are also able to produce the control motion using the ultrasonic sensors and other accelerometer sensors like that. In order to get high efficiency, we use a modern digital gyroscope and an inclinometer. Let's see about the digital gyroscope and the digital inclinometers. The gyroscope returns the instantaneous angular velocity because it is used to determine the angular velocity of a wheel. And the digital inclinometer is a capacitive type and a liquid based sensors. It is used to generate the pulse width modulation output, which is related to the angular velocity. It can able to produce a effective measuring range of only plus or minus 30 degrees. Let's see about the sensor arrangement and the functional systems. The digital gyroscope and the digital inclinometers are installed on the balancing robot system and they are used to measure the tilt angle as well as the angular velocity of a wheel. In order to get the high efficiency, we are going to fusing the sensors together and filter the output of the sensors using a Kalman filter. Besides the gyroscope, the output of the gyroscope and inclinometers are given to the encoder present in the actuators. These type of encoders are capable to providing 3,495 counts per shaft revolutions. We are going to see about the block diagram of this project. The block diagram comprises of a inclinometer and a gyroscope. They are the most important portions. And we have the encoders of left and right wheels. They are multiplexed and given to the control system. And then the control system give commands to the left motor and the right motor using the PID controller. And the left actuator and the right actuator give motion to the wheels. These give a balanced motion. Actually, the balanced motion by measuring the tilt angle and the angular velocity of the wheels, it gives a balancing locomotion to the two-wheeled balancing robots. Let's see about the modern uses of this two-wheeled balancing robots. In the modern days, these type of robots are presently used in the name of Zigway. These types of robots are mainly used in scientific labs and small distance locomotion inside a lab or office. These are used. It saves many times of traveling inside a lab. It gives a fastest and easiest locomotion way for a small distance traveling, like to travel from one apartment to apartment inside a campus, like that. These vehicles are used mainly in institutions, offices, and mainly actually it was intensively used in labs like militaries and many other important places. Thank you. Thanks for your golden opportunity. Thanks. Friends, we have some programs for to control the self-balancing robot. Let's see the features in this program. First, we have some files to include. They are for the left servo and the right servo, and we have a LED to indicate the power supply and the operation running condition of the robot, and have switches and the speakers. And we have some values to identify the counter, some of the counts and some of the angles to be noted for the microcontroller. And we have we have noted the critical angle of a critical level of a tilt angle and the angular velocity to be identified to give a balance for the robot. It was most important part in that. And we have a loop we have a port sensor and a ping sensor for extras. We have program for the PID controller to control both the encoders and the gyroscope and the inclinometers. And the end we have the balancing level by measuring in case of measuring the tilt angle by the inclinometer and the angular velocity by the gyroscope. It must need at critical angle to identify this level to this level. We have given some count programs by giving a counter in this program. That's all. Thank you.